This problem says find the equation of the parabola. And then it says find 2 points that define the lattice rectum. And then it says graph the equation. So what we're going to do here is we're going to do all 3 of those things. So this also includes the lattice rectum that I kind of talked about previously. So the first thing I always do in these, so a lot of times you say find the equation of the parabola, but what I look at first is just the graph of those 2 points. And that tells me so much about the equation itself. Okay, so anyway, so first it says the focus is at 0, 2. So I'm just going to graph that 0, 2. Oops, I still got it on black. I'll change my color really quick. There it is. So our point's right there. So then it says our vertex is at 0, 0. So that's going to be here. All right, so there we go. Those are our 2 points. So that tells us so much about this right away. This tells us eventually, since the focus is here and the vertex is down there, remember it always opens in the direction of the focus if I have the vertex. So that tells you right away where this thing's going to open at. So anyways, I'm not going to draw that in there yet, but I did kind of want to let you know, oops, where that was. Okay, so now what we're going to do is that sets us up for which formula do I actually use here. And now that's what we're going to draw. Now, since we know this thing opens up, do you guys remember the picture in detail? There it is. Okay, so when I actually look at this picture here, I realize that, see, my focus is up here. Okay, my vertex is there, and that's all the information we have. But we know this distance here is my A. So that means this is also that same distance A. Do you remember that? And that's going to give us our directrix. So right away we get our directrix because we know A. Okay, so that's what we're going to do now. So now from the picture, we have our A here. So this is going to be our A. And that A is 2. All right, so all we're going to do now is set up this equation because we have everything for the equation. And do you guys remember the formula for that? Now remembering it's open upward, so that means think about this. We dealt with these before, y equals x squared. So we have an understanding that we're going to have an x squared in this since it opens up or if it opens up or down. So that's what we're dealing with here. So then our formula isn't going to be this, but it's going to be x squared equals 4ay. So that's going to be our formula we're going to use. And what did we say A was? A was 2. So our equation then is going to be x squared equals 4 times 2y. So then our equation is x squared equals 8y. So there it is. Now from there, we can actually graph this thing. We know the directrix, right? Okay, so we can put all of those values in right away. So in essence, I kind of do those together. The lattice rectum we'll talk about in a second, but let's just do this graph now. So our directrix then is 2 down, so that's going to be down here because it's 2 away from the vertex. Now remember that A is in reference to that vertex, so make sure you keep that in mind as you graph all these. And I'll have to write y equals -2 to get full credit. Okay, I don't really need to have this distance of -2 or this distance of 2 in here. So I can actually take that out now. That was just for our understanding, which I thought was kind of handy there. So now what we're going to do is we're going to actually draw this around. Now we'll need 2 other points in order to do this, and that's why they pick the lattice rectum most of the time. When they're actually graphing these, that's why they put those in, because it gives us a nice width of our parabola. So now what I'm going to do is I'm going to actually find those 2 points before I finish the curve. So we know the focus is 0, 2, and since I'm actually plugging in a number here, I'm going to plug in that 2 for my y, because this is the one I'm going to use, since I know the focus is 0, 2. I can plug that 2 in for y and get my x values, and that'll give me those lattice rectums. So always the direction you're going in, that's the letter you pick. So since I'm going in the y, this thing's going to open in the y direction. So that means I'm going to pick my y value. If I open in the x direction, then I'm going to pick an x value. And we'll play around with that some more. Now remember, I should get 2 values for that, and that's kind of the other side of it. So now that's going to give me x squared equals 8, and I'm plugging in 2 for my y, so that's going to be 16, so x squared equals 16. Then I square root both sides, so then x equals plus or minus 4. Remember, when we square root, we have to plus or minus. So the 2 points I end up with here are going to be, what did I plug in again? I plugged in a 2 for my y. So make sure you don't mix those up, and that's easy to do with these. So then this is going to be a negative 4, 2, because I plugged in 2 for my y and I got a positive negative for my x. So just put those where those go. All right, so now what we're going to do is we're going to graph those points, and then now we'll have a complete graph once we put those in. All right, so here it is. So we're going to go negative 4, so 1, 2, 3, 4, and then up 2. Here's our point. And then we're going to go in the other direction, so 1, 2, 3, 4, and then we're going to go up 2. So that's going to put us here. And then now we can actually draw this graph. So there's a complete graph. And also we should label the vertex. The vertex isn't always going to be at the origin, just from what we've seen so far. Keeps it simple, gives us a nice idea of the picture. So we graphed the equation, that's check for number 3. We found the 2 points for the lattice rectum, that's a check. And then we found the equation of the parabola. So I'm just going to circle all of our answers here, because there is a lot of information here. And I'm not going to circle it, but the whole graph here. Well, actually, I'll circle it. So for this problem, that was all of our answers. Everything else was kind of here or there. But there it is.